Hello and welcome to Empowered Learning. This video is about absolute value. In particular, we want to define what absolute value is and be able to properly evaluate it. So in short, the absolute value of a real number A, and it's denoted by these two bars that are on either side of A, we see that it represents the distance between A and 0 on a number line. So for instance, here, if we wanted to find out what the absolute value of -4 is, it is just the distance 4 is from 0 on the number line. And if we look here, if we start here at -4, we go 1, 2, 3, 4 units away from 0. Same thing for 5. The absolute value of 5, if we start here, that's 1, 2, 3, 4, 5 units away from 0. And so absolute value is how we express distance in mathematics. So that's simply what it is. And so one of the common things that I've seen students do when they answer absolute value questions wrong is they think it's always the opposite of whatever the number is. So for instance, if we said the absolute value of 4, I know I've seen students say, well, the answer is -4 because it's always the opposite. And that's not true. When we talk about distance, we know that distance could never be negative. If we could have negative distance, then we would all have brand new cars with 0 miles on it, because every time you would drive somewhere and then come back, your speedometer would say 0. But of course, we know that that doesn't make any sense, right? So that's why distance could never be negative, okay? Now, another reason for that, and I'll just throw this in here before we start with the examples, is that if we actually draw the absolute value function and what it looks like a V. So it looks something like this. And so if you notice here, we do not have any part of this graph below the x-axis. And so if we did, that would represent that distance could be negative. But since we don't have anything, there's no part of this graph that's below the x-axis, then we know that we cannot express distance as a negative number ever, okay? All right, so let's move on to some of the examples. So we just want to find the absolute value of each number. So the distance that 9 is away from 0 on the number line is just 9. The distance that -6 is away from 0 on the number line is a distance of 6 units. The distance that the number -4/5 is, of course, is 4/5. And so again, if you notice, even though I should say absolute value, I'm actually interpreting it as what is the distance that number is from 0 on the number line. So I'm saying it that way on purpose so that you get a sense for what the absolute value actually means. Of course, once you get to that point, then you can just say absolute value and just answer the question correctly. So here, the absolute value of 0. So how far is 0 away from 0 on the number line? Yep, that's right. It's 0 units, right? You didn't have to move anywhere. And so that is okay. Remember, we said that distance cannot be negative. We never said it cannot be 0. If I stand in one place and I say, how far do I travel if I went nowhere? I went, a distance of 0, whatever units I'm measuring it, okay? All right, so let's move on to some other examples. All right, so we know that the absolute value of 10 is just the distance that 10 is away from 0 on the number line, which is just 10 units. Now for F, what we're doing here is adding in some extra operations. And so the point of this is to realize that when we have negative times absolute value of 10, we actually should be interpreting it this way. And of course, according to order of operation, we need to do it inside the grouping symbols first, which in this case is an absolute value. So when we do this, we know that absolute value of negative 10, this part just ends up being 10. So that's why you see that there. And of course, here the negative 1 that's there is just interpreted as a negative. And so you're really looking at this like it's negative 1 times positive 10, which gives you a negative 10. So that's how we figure that out. So similarly, if we look at this situation here, we look at this as a negative 1 times whatever absolute value of negative 5 is. And we know that negative 5 is 5 units away from 0 on the number line, so it looks like this. And so, of course, a negative 1 times positive 5 is a negative 5. Now, of course, I did this because some people, when they do this originally, they think, all right, well, I need to distribute this negative over, and the negative times a negative is a positive, and they write the answer like this. And that's incorrect. And so, to show you the difference, if I had this, then that would be true. But notice here I have parentheses or grouping symbols here versus absolute value sign. So absolute value sign means something totally different than just a regular parenthesis. So in this case, I really could interpret this as a negative 1 times a negative 5, which ends up being a positive 5. But here I can't do that because absolute value of this means something else. Okay? And so similarly for example H here, we see that we need to work inside of our absolute value sign first. So in here looks a lot like this example. So here we can say a negative times negative is a positive. And then of course, all that just simplifies to 15. We know that the absolute value of 15 is just 15. And now we interpret this as being negative, let me try to fix that, as a negative 1 times 15. And of course, negative 1 times positive 15 is a negative 15. So this concludes the lesson on absolute value. I hope that this video helped clear some of the myths and some of the commonly made mistakes about evaluating absolute values, and hope you enjoyed it. Take care.